Welcome back to Control X Engineering. In today's tutorial, we are diving into one of the most practical and powerful features in industrial automation: recipes in PLC programming. If you have ever needed to change machine parameters on the fly without touching a single line of code or entering several set points manually, then recipes are your best friend. Whether it's a production line for different product variants or machine settings for operators, recipes make your PLC smarter and your life easier. Today, we'll explore how to get started with using and implementing recipes in TwinCAT. We'll go through practical examples of defining the recipes that we will need and see how we can use the library functions to create, delete, read, and save recipes. So let's get started. The complete documentation for working with recipes can be found at Beckhoff's Information System website. What are recipes? Imagine you are in a kitchen. You want to make spaghetti one day and pizza the next. Each dish has its own recipe, which is a list of ingredients and instructions. Spaghetti might require a certain amount of pasta and salt, let's say 10 minutes of boiling, while pizza might need dough, tomato sauce, and 12 minutes of baking at a certain temperature. Now think of your PLC control machine as the kitchen. It might be a packing line, a filling station, or even a CNC machine. Depending on the product or task at hand, it needs different settings, just like ingredients and instructions. That's exactly what a recipe in the PLC world. It is a collection of preset values for variables in the PLC that can be saved to file and loaded when needed. It's a way to switch between machine configurations without reprogramming different values every time. Recipes in the PLC help save time, avoid manual errors, and make your machine more flexible for real world production. They help machine operators to easily load different settings or set point values when switching between product variants or product SKUs. They also eliminate the need for manual entry, thereby minimizing or eliminating operator errors. Let's look at an industrial application where recipes are generally used, and then we'll implement the example in TwinCAT. Let's look at the example of blown film extrusion, which is a manufacturing process used to create thin plastic films from polymer resins. These resins are melted, formed into a tube, and inflated into a bubble to create uniform sheets of plastic. Plastic pellets are loaded into a hopper, where they begin their journey. The extruder applies heat and pressure, melting the plastic as it moves through the screw. The melted plastic is forced through a circular die, forming a hollow tube. Compressed air blows into the tube, expanding it into a bubble of thin film of plastic. The bubble then passes through cooling zones to maintain shape and strength. The bubble is then collapsed and pulled through rollers, flattened, and wound onto large spools for storage and cutting at the winder. For the purposes of this tutorial, we'll focus on the extruder part only. The extruder is the core component of the blown film extrusion process, responsible for melting and homogenizing the polymer before it is shaped into a film. It consists of a feed hopper, a rotating screw, and a heated barrel that work together to process the raw materials efficiently. Temperature regulation is critical in extrusion process to ensure proper melting, mixing, and flow of the polymer. The extruder barrel is divided into multiple heating zones, each precisely controlled to maintain the required temperature profile. The screw speed determines the rate at which the polymer is processed and extruded. The speed is controlled using a VFD. The motor speed is adjusted based on the required output and material properties. PLC recipes are used for automating the barrel temperature and screw speed settings in the polymer extrusion process. Different polymers require specific processing conditions to achieve the optimal melt quality, viscosity, and final product characteristics. The machine operator simply selects the appropriate recipe from the HMI, which has predefined settings for required screw speed and the temperatures for the various heat zones. What the recipe does is loads the pre-configured set points to the appropriate PLC variables. The PLC then applies these values and adjusts the screw speed and heat zones according to the operator's selected recipe. We will implement this recipe management system in today's tutorial in TwinCAT. In order to use recipes in TwinCAT, first we have to add the recipe management library into our PLC project. This can be done easily. Navigate to the project tree and right-click on References in your PLC project and select Add Library. In the pop-up dialog box, search for and select Recipe Management. This will add the recipe management library to your project. The methods for the function block recipe man commands enables the recipes to be managed programmatically in the PLC code. I will cover a few of these for our tutorial, which will enable us to create, load, save, and delete recipes. The first method we'll be reviewing is the create method. This creates a new recipe in the specified recipe definition. It subsequently reads the current PLC values into the new recipe and saves it as a recipe file with a standard name. The standard name is of the format as shown, where the first part is the user defined name for the new recipe that the operator wants to save. The middle part of the file name is the recipe definition that the PLC programmer gave to the collection of variables for that recipe. This is defined in Recipe Manager, which we will cover later. And the last part is the file extension for the recipe file, which was defined also by the PLC programmer in Recipe Manager. This method has two inputs. Recipe definition name is the name of the recipe defined in the Recipe Manager by the PLC programmer and is the middle part of the file name. We will cover Recipe Manager after we review the various methods. Recipe name is the name that the operator will give for that recipe to be created. From our extruder example, the PLC programmer will use a recipe manager to create a recipe definition and add the screw speed and the 5 temperatures and give the definition a name. This part is done during the programming stage. This will allow a machine operator to be able to enter the values for screw speed and the 5 temperatures from the HMI and create a new recipe file and specify a recipe name appropriate for those values he just entered. The machine operator can use the same definition to create multiple recipes, each with different values for screw speed and the 5 temperatures. The method also returns a value of type double word to indicate the status of the operation. We will look at the return value types later to see what they mean. This method deletes a recipe from the recipe definition and returns a value indicating the status of the delete operation. This method loads the specified recipe file and writes the recipe into the PLC variables as per the recipe definition. The file must be stored under the standard name as described earlier. Any alteration to the file name structure will render the recipe file unrecognizable. It also has a return value of type double word to indicate the status of the load operation. This method reads the current PLC values into the recipe and saves it to an existing recipe file. This function allows operators to modify existing recipes with new values and save them back to the same file. The existing contents of the files are overwritten. It has a return value that indicates the status of the read and save operation. Let's look at another two methods that we will be using in the hands-on portion of this tutorial. The first one is the get recipe names. This method returns the recipe names in a recipe definition. To store the recipe names, we have to pass an array of string data type. This is done by using pointers, as we will see later. The other method is the get recipe count method. This one simply returns the number of recipe files stored for a given recipe definition. The various return values of the functions described so far are contained in the GVL return values. This screenshot is from the recipe management library under your project references. There you will find these return values of type unsigned double integer along with the description of each return type. I have mentioned Recipe Manager a few times now. This is where recipes are defined and other settings like storage location, file extension, etc. are defined by the PLC programmer. To add the Recipe Manager, right-click on the PLC project, click Add, then select Recipe Manager. This will add the Recipe Manager to your PLC project. Double-click on it to open the Recipe Manager settings page. These are the recipe file storage settings. For file storage type, we can choose between text or binary format. Personally, I prefer to use text format so that it's easy to read the recipe files and to modify them externally. File path defines where the user created recipes will be saved, and file extension is self-explanatory. Now we can add a recipe definition to the manager. Right-click and select Add Recipe Definition. Give a suitable name for this definition. For example, we could call this one my recipe underscore extruder, since our recipe definition is for the extruder variables. This is where we can add the collection of variables for that particular recipe. We can optionally also define minimum and maximum values for each variable, so that if the operator enters incorrect values which are outside of a valid range, then the corresponding minimum or maximum value will be saved instead. Now that we have covered the basics, let's switch over to Andrew, who will demonstrate our application programming and show the implementation of recipes in TwinCAT. If you're enjoying this tutorial so far, please hit that subscribe button for more PLC tutorials like this one.
Hi everyone, this is Andrew, and today I will be demonstrating how to implement recipes in TwinCAT. Let's start by adding a new PLC project to our solution. Okay, the PLC project has been created. First thing I want to add is a DUT for our extruder variables from Ocul's application example. This DUT will contain the variables for the screw speed and the 5 temperature variables. DUT is done. Let's save it. Next, I'll create a GVL and create an instance of this structure for one of the extruders on this machine. GVL is done. Let's save it. Now, let's add the recipe management library to our references. In the Add Library dialog box, type Recipe, and from the list select Recipe Management Library. The library is now added to our project. Let's take a look at it. As we can see, it has some variables defined as GVL named return values, as well as some methods under recipe man commands. Akil covered some of the methods during his presentation, and we will be using those methods in this tutorial to create a basic recipe management system for this application. Next, I will be adding the recipe manager. For this, right-click on the PLC project and Add Recipe Manager. On the pop-up dialog box, hit Open. Here we will configure the storage settings for the recipes. For this tutorial, I will create a folder on my desktop and set that as the recipe storage location. This is where all user-created recipes will be saved. Now I'll point the file path to this folder, and we can close and save the recipe manager settings. The final step in the setup process is adding a recipe definition in the recipe manager. For our extruder variables, I will call the definition my recipe extruder. This name will be used in the PLC programming stage later. Under the variable section is where we add the variables for the recipe definition. Since I have created a single structure containing my variables, I only need to add one item here. This is particularly helpful if you have a lot of variables. Grouping them into a structure is efficient and saves time. Otherwise, I would have had to add multiple variables one by one here. This step has now been completed. I can close and save this definition. The recipe setup is now completed. The next step is programming the logic to handle the recipe methods. Let's get coding. I'll add a new program to handle the recipe methods, so let's do that first. For this example, I will be coding it using structured text. First step is to create all the required variables. We will need to create an instance of the recipe man commands and string variables for the recipe definition name, and another string to store the user file name for the recipes to be saved. Next, I will need trigger bits for each action like create, save, load, delete, etc. Next, I need some variables of type double word to store the return values of each method. These variables are optional and store the result of the chosen action. So I will create one for each of the 5 actions that we will be programming today. Lastly, I need few more variables for some of the logic. Now for the logic. I will start by adding actions or subprograms for each of the required functionality. Let's start with the create recipe function. Again, I will program these actions in structured text. The recipe create action will be triggered when the create bit becomes true. This will invoice the create recipe method, and I will pass the recipe definition and file name as inputs to this method. After the method has been executed, I will reset the trigger bit to false for next use. Also reset the file name to null string for next use. Speaking of file name, we need to check that the file name string is not empty. Otherwise, the create method will return error. So let's add a check for empty file name. Now the create method will not be executed unless the valid file name bit is true. Crisis averted, and our action program is completed. Let's close and save. Next, I'll add an action for the delete recipe function, which will make use of the delete method. Here we have to specify the name of the recipe to be deleted. Again, the string cannot be empty. So I will add a check for null string, just like I did for the create action. In this case, we can just return from this action if the string is empty and not execute the delete method. Action is done. Let's close and save. Similarly, I will add actions for getting recipe count, recipe names, loading, and saving recipes. Sit back and enjoy. This will take a few moments. All actions have been created. Back to the recipe handler program. Let's add calls to those actions. Close and save this program. Our recipe handler program is ready. Let's add a call to this program from the main program. Programming is now complete. Let's activate the PLC project and test it out. PLC is now in run mode. Let's log in and test our logic. Here's our GVL structure containing the variables for the extruder. I'll rearrange the windows so that we can see the variables and the code together. Okay, I have the code for the create recipe action open at the bottom. Let's enter some values and create our first recipe. Okay, our variables are loaded. The first line in our code checks for a valid file name. Currently the bit is false because I have not entered a file name yet. If I try to trigger the create recipe function, the if statement will not execute. I'll enter a name for the recipe. Let's call it Extruder1. Now I will trigger the create recipe bit. Pay attention to the recipe folder. A new file should appear here. And there it is. We just created our first recipe. Let's check it out. Since we configure the recipes to be textual, I can open it in Notepad and see the contents. And here are our set points from the GVL. That's great. For the rest of the tutorial, we will interact with an HMI instead. I have already created a visualization with the required recipe functions. Let's check it out. Some text buttons are grayed out because we have not yet loaded the recipe names. Remember the get recipe method? This fetches all the recipe names from the recipe folder. Now our buttons are available for use. Let's try creating a new recipe from the HMI this time. Let's call this Extruder2. And we can see another recipe file created in the folder. Similarly, I'll create another one. We have 3 save recipes now. My recipe list on the HMI still shows 1 recipe. I can refresh the list by triggering get recipe names. Now we can see all 3 recipes. Let's load the first recipe and modify it. I'll change the speed set point and save the recipe without creating a new one. Let's check the saved recipe file. It worked. My new value is reflected in the recipe file. Let's load one of the saved recipes to test the load recipe function. We can see the variables now updated with values from recipe 2. I will check recipe 3, and it works. We can also modify the recipe file externally and then load the new values in the PLC. Here I will make a modification to recipe file 2 and save the file. Let's load the modified recipe and see what we get. As you can see, we can easily modify recipe files externally using a text editor. I can revert the recipe to the original value from the HMI and save it again. So I have demonstrated multiple ways to modify recipes. Lastly, I want to demonstrate the delete recipe function. I will be deleting recipe 2. We select the recipe name and call the delete recipe method. As we can see, recipe file 2 gets deleted from the folder. And if I refresh the list, it no longer shows up. That's all for this tutorial. Today, we learned how to integrate basic recipe management in a TwinCAT project. We created actions for the basic recipe functions like create, save, load, and delete. Hope you enjoyed today's tutorial. See you guys in the next one.
That's all for today's video. If you have any questions or suggestions about today's video, please leave them in the comments below. If you found this video helpful, then please consider subscribing so you don't miss out on future tutorials. As always, thank you for watching and keep innovating.